at the top of the board here, I've recapped the problem that we're trying to work on and how far we've gotten. We're trying to prove that the limit as x goes to 2 of 1 minus 3x is negative 5. We did some informal work, and we found that if we were given a positive number epsilon, that was our tolerance for how close we wanted our y values to get to negative 5, we found this, what I'm calling a candidate for delta, that delta could be epsilon over 3. So what that means is if somebody said, I bet you can't get within 1 unit of negative 5, we would say, oh yeah? Well, our delta is going to be 1/3. We would take the epsilon that we're given and just divide by 3. If they said, I bet you can't get within 1/10, we would say, let's let delta be 1/30. We would take 1/3 of that. Okay, so here I just remind us of our goal. If we're given an epsilon, if we're given a standard of closeness for the y values, we want to find a delta. We think we have, but we need to demonstrate that this such that part is true. And it's such that if this is true, then that is true. Okay. So that if we're close to but not equal to 2 in the x values, the y values will be close to negative 5, using epsilon as our standard of closeness. Okay. Now, the first 2 lines of a formal proof like this are both going to just begin with the word let. If I'm doing a proof, I need to introduce the things I'm talking about. So let's let epsilon be bigger than 0. That's sort of just acknowledging the challenge, but I'm going to be talking about this thing. Okay? This was just the problem up here. Here, below this line is where my formal work is. I just acknowledge the challenge. I have been given a standard of closeness for my y values. And now I'm going to tell you how I'm going to meet the challenge. I'm going to introduce delta. So I'm going to let delta be epsilon over 3. Okay. Notice, because I'm describing delta in terms of epsilon, I have to introduce epsilon first. Okay, so now I want to prove this if-then statement. So we have to think about how would we prove an if-then statement. So I want to just make an analogy. Let's suppose that instead of being in a math class, or your bedroom, wherever it is that you're watching these videos, let's suppose that instead of this, we're in a chemistry lab. And we say, I think if I mix these 2 chemicals together, then there will be an explosion. Okay, so that's an if-then statement. If I mix the chemicals, then they will explode. Okay. How would I test that hypothesis? What would I do? Yes, I would do an experiment. I would actually mix the 2 chemicals, and then I would run for cover and hide, because if I'm right and there is an explosion, I don't want to be anywhere near it. Okay? But when you do an experiment in a science class, you're making the if part true. And then you're just observing what follows so that you can observe whether the then part actually happens or not. So we need to do that too. But we don't have any sort of fancy lab equipment. We don't have chemicals that we're going to be mixing together. What we're going to do is we're going to perform a thought experiment. Our lab is our brain. Okay. So in that lab, here's what I'm going to do. I'm going to suppose that the if part is true, that 0 is less than the absolute value of x minus 2 is less than delta. Okay. And a lot of times people say, what gives you the authority to do that? Well, I don't care what happens if this isn't true. I'm only claiming that this happens if this is true. So I need to consider what happens if that is true. I need to perform the experiment. Okay. Now, because we are performing an experiment, if you want to wear safety goggles while you write your proofs, you may do that. I had a wonderful student one year. He came into the first exam wearing safety goggles, and I just cracked up. It was fabulous. And he was so committed to wearing them for the entire exam, and they kept fogging up. And so he kept cleaning them, and he was like, I'm so determined, I'm going to wear my safety goggles. And he did fabulous on the exam. Okay. Anyway, That's what we do. So the first three lines will always follow this pattern. Let, suppose. Okay. Now, I need to show that this then part is true. So I want to switch gears to talking about this thing. So a really nice transition word, and I'm going to just erase everything except this. This is, I'm just going to label as my goal. Okay. And I'm going to bump up here on the board. Really nice transition word is the word consider. So I'm just going to say consider the absolute value of 1 minus 3x minus a negative 5. So we're switching gears. I've introduced everything that I'm going to play with. Okay. And now I'm going to consider this stuff right here. Okay. And actually, maybe want to say just one more thing here. Sorry, I should have said this first. If this is true, there are going to be times when I need this part. As I said, for this particular problem, we don't really need that part of it. We just need this part because nothing weird happens at 2. So I'm just going to spell out that what this means is that the absolute value of x minus 2 is less than epsilon over 3. What happened to this part of the inequality? It's still true. This is the part that's going to be useful. So all I've done is said, hey, if this whole thing is true, then this part is true. And I've told you what delta is, so I can just plug that in. I'm going to put a little star by that because we're going to need to refer back to it later on. Okay, so I apologize. I should have done that before I said consider this. But now we're ready to consider this. And I'm going to try to simplify this and show that it's less than epsilon. And all I have to work with is that I know that this inequality is true. The work I'm about to do is going to feel very repetitive. It is very repetitive because I'm basically going to do the work that we did in our informal work. The difference is in the informal work, I started by assuming that this statement was true, that I had this true inequality. Now, I'm just working with this expression and simplifying it to see what I can say about it. But the algebra is going to be very similar because I'm going to say, okay, well, the absolute value of 1 minus 3x minus a negative 5. That would be equal to the absolute value of 1 minus 3x plus 5. Just doing the arithmetic. I can combine the 1 and the 5. So that's equal to the absolute value of negative 3x plus 6. That's equal to the absolute value of negative 3 times x minus 2. Just factoring that out. Okay. Now, I'm going through this fairly quickly because I did it before. If I had a bigger board, I'd actually still have that work from my informal work still up on the board, and I could look back over it to remind myself what I wanted to do next. Okay. All right. So this is equal to the absolute value of negative 3 times the absolute value of x minus 2, which is equal to 3 times the absolute value of x minus 2. Now, everything that we've done so far has involved equality. So I was talking about this. I'm still talking about it. I'm still talking about that same thing. Still talking about that same thing. Still talking about that same thing. But now, I'm going to say, oh, but I know something about that part of it. Because I know that that part of it is smaller than epsilon over 3. So that means this must be smaller than 3 times epsilon over 3, which is epsilon. That's exactly what we wanted to show. We started with this through a sequence of equalities and less thans. There was no greater than ever in here. It was all equals or less thans. Through this series of equal and less thans, we showed that it's less than epsilon, which is exactly what we needed to do, and so we are essentially done. I like to, since this is kind of abstract, I like to then write, thus the limit as x goes to 2 of 1 minus 3x is negative 5. That just makes it clear to anybody who's reading my proof is that the reason that I stopped isn't that I was just tired or bored or confused. I stopped because I had actually completed the task that I had been trying to accomplish. Okay. So again, this work, very, very redundant with what we did in our informal work. The difference is every one of these equal signs or this inequality I can justify. The equality is justified by just basic rules of arithmetic and algebra, and this would be justified by referring back to star, that I knew that this factor was less than epsilon over 3. Okay. So I didn't start with an inequality where I could manipulate both sides. That was the informal work. Here, I started with an expression, wrote things that I knew were true about that expression, and proved that the thing that I wanted to be true, that it was smaller than epsilon, was in fact true. Excellent.